All right, so I'm going to help you guys get started on your independent practice. Number 1 says Talia plays a board game with a friend. She uses a frequency table to record the results for each roll of a standard die. So it's showing you that here's the number rolled. So the number 1 was rolled 1, 2, 3, 4 times. The number 2 was rolled 2 times. The number 3 was rolled 6 times. So based on the data in the frequency table, what is the probability of rolling a 5 on the next roll? So we're looking here at the number 5, and the frequency for the number 5 is 5, 6, 7, 8. So 8 for the number 5, but we know that we're always going to need the total. So let's find the total number of times she rolled a die. So we have 1 time she got 6, 5 times she got 4, 6 times she got a 3, 2 times she got a 2, and 4 times she got a 1. So 4 plus 2 is 6, 6 plus 6 is 12, 12 plus 5 is 17. Gonna go down 18, 18 plus 8 is 36. 18 plus 8 is 26. Man, my brain's off today. Okay. So based on the data, the probability of a 5. So the probability of rolling a 5 is 8 out of 26. And then we're going to go ahead and simplify, right? I know we can divide them both by 2. So 8 divided by 2 is 4. 26 divided by 2 is 13. Can you simplify again? No, because 13 is a prime number. All right, so now the second one says, based on the data in the frequency table, what is the probability of rolling a 2 or a 3 on the next roll? Okay, so a 2 or a 3. So one or the other. So 2 and 3. So the probability of a 2 or 3 is 2 plus 6, right? So that's 8 over 26, which is equal to 4 over 13. We already figured it out. So in this situation, based on the experimental probability, the probability of rolling a 2 or a 3 is equal to the probability of rolling a 5, even though we know that theoretically we should get the same of each number. It's showing that in this experiment, that's not the case. All right, so number 2. Without looking, Carrie selects a numbered tile from the tiles shown below. What is the probability that the tile Carrie selects shows a prime number? So remember our vocabulary. A prime number is a number that can only be divided by 1 and itself. Prime numbers do not include the number 1. So we're going to cross that out. Is 2 a prime number? Yes, I'm going to circle that. 3? Yes. 4? No, that's divisible by 2. 5? Yes. 6? No. 7? Yes. 8? No. So the probability of a prime number, how many prime numbers did we circle? 1, 2, 3, 4. Over how many tiles? 1, 2, 3, 4, 5, 6, 7, 8. 4 over 8. You can simplify to 1 over 2. All right, moving right along to number 3. It says Mr. Wynn spins a spinner with 5 equal sections 50 times. The results are noted in the spinner shown below. Mr. Wynn spins a second spinner with 3 equal sections 50 times. The results are recorded in the table below. So this is the first spinner and this is the second. So based on the data, what is the experimental probability that he will spin a diamond and a C if he spins each spinner 1 time? So the probability of a diamond and a C. And we know that the total for each is 50 because it tells us. All right. So first we want to know the probability of a diamond. So the probability of a diamond is, they say 10 out of 50, which we can simplify, right? Cross it out to 1 over 5. And a C. C is, so probability of a C is 16 over 50. They're both even numbers, so I'm going to go ahead and divide by 2. So I have 8 over 25. Now, what do you do with two events, right? We always multiply them. So now we have 1 over 5 times 8 over 25. 1 times 8 is 8. And 5 times 25. 5 times 5 is 25. 2 times 5 is 10, 11, 12. So you have 8 over 125. So now let's look at B. B says, based on the data, what is the experimental probability that he will spin a triangle and an A if he spins each spinner one time? So now I'm looking at a triangle and an A. So same process, right? So probability of a triangle is 10 over 50, which is 1 over 5, which is actually the same. And then the probability of the letter A, well, A was spun 20 out of 50 times. So that's 2 out of 5 times. And again, probability of compound events, we're going to go ahead and multiply 1 over 5 times 2 over 5. 1 times 2 is 2. 5 times 5 is 25. All right, so it's much more likely to get a triangle and an A than a diamond and a C. Moving right along to number 4. Molly has a jar containing 4 yellow, 3 blue, 3 green, and 2 orange marbles. If Molly removes 1 marble without looking, records the color, and places the marble back in the jar before drawing again, what is the probability she will remove 2 yellow marbles? All right, so just to make it a little bit easier to see, I'm going to go ahead and organize it over here. So she has 4 yellow. 1, 2, 3, 4. 3 blue. 1, 2, 3. 3 green. 1, 2, 3. And 2 orange. 1, 2. Okay, so she wants to know the probability of getting 2 yellow marbles, and she places the marble back in the jar. So that's with replacement. So that means it's independent or dependent? Independent. Does our total change? No. So the probability of a yellow marble is 1, 2, 3, 4. So 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marbles. 4 over 12 can be simplified. If you divide by 4, 1 over 3. Now, if we put it back in, then it doesn't change, so I can use this probability twice. So 1 over 3, and again, it's a compound event, times 1 over 3. 1 times 1 is 1, 3 times 3 is 9. So 1 over 9 is going to be our answer here. So B says, if Molly removes 1 marble without looking, records the color, does not replace it before drawing again, what is the probability she will remove 2 yellow marbles? Okay, so we know that the probability of yellow to start with was 1 over 3. Now it's saying she left it out. She didn't put it back. So the probability of yellow the second time, well, there's 1 less yellow, so there's 1, 2, 3 yellows. And then our total is 11. Good, because there's 1 less marble. So now we have 1 over 3 times 3 over 11. And a quick trick, what you can do is you can cross out, if there's the same number in the diagonal, they actually cancel each other because it's essentially 1. So 3 over 3. So 1 times 1 is 1. 1 times 11 is 11. If that confuses you, then you just have to simplify after. 1 times 3 is 3. 3 times 11 is 33. And then you can cancel it and know that it's 1 over 11. All right. Next problem. Number 5. A bag of game markers contains 4 red markers, 5 blue markers, 3 yellow markers, 3 green markers. If Mario reaches into the bag, pulls out a game marker without looking, what is the probability he will not pull out a blue marker? Okay, so first let's go ahead and write out our sample space. So we have 4 red, 1, 2, 3, 4, 5 blue, 1, 2, 3, 4, 5, 3 yellow, 1, 2, 3, and 3 green. 1, 2, 3. Okay. He reaches into the bag and pulls it out. What's the probability of not pulling out a blue marker? So probability of not blue. Okay. So we have 2 ways of doing this. We can either find the probability of blue and find the complement, or we can figure out how many are not blue. So if we want to just find out how many are not blue, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 that are not blue out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. And you can simplify that by 5, so that's 2 over 3. So let's go ahead and double check it. If 2 over 3 is the probability of not blue, and then the probability of blue would give us our total, right? So total would be 3 over 3. So how many do you have to add to 2 to get to 3? So 2 plus 1 is 3. So blue would be 1 out of 3. But there's 15 marbles. So 1 out of 3 is how many out of 15? So 3 times 5 is 15. 1 times 5 is 5. So 5 out of 15. 1, 2, 3, 4, 5. So 5 blue. So that's right. So the probability of not blue is 2 out of 3. All right, moving right along. Number 6. 2 bags each contain 5 letter tiles. The sample space is shown below. Jennifer selects 1 tile from each bag without looking. What is the probability she selects 2 vowels? Okay, so are they dependent or independent? Independent because they're 2 separate bags. You're taking 1 out of 1 bag and then 1 out of the second bag. So she selects 1 tile, probability of vowels. So let's look at bag 1. The probability of a vowel in bag 1. So A, E, I, O, and U are vowels, right? A, E, I, O, and U. It's an O. So A, U, and I. Okay, hang on. Let me fix it. Sorry, so looking back at bag 1, vowels A, I, and U. So the probability of a vowel in bag 1 is 3 out of 1, 2, 3, 4, 5. So 3 out of 5 in bag 1. Now let's see. E and O in bag 2. So the probability of a vowel in bag 2 is 2 out of 5. So now what do we do with our 2 probabilities? We just multiply them to find the probability of getting a vowel in one and then the other. So 3 over 5 times 2 over 5. 2 times 3 is 6. 5 times 5 is 25. Good job. All right, guys, you try the last couple on your own.